The idea of continuations is actually a very simple idea. So let's take a look at how it works. Let's suppose I want to make some tea by boiling water and pouring it into the cup. Now it's obvious that those two tasks should be one after another. So first I boil the water, then I pour it into a cup. Now we can certainly do it using task.wait and whatever, but there is a different way, an explicit way of specifying that there is a continuation in place. So I can have a task for boiling the water. So I'll do task.factory.startNew, and here I'll just output on the command line console.writeLine boiling water. But instead of just doing a wait on it and then continuing scheduling my second task, what I'm going to say is that I now want to continue this task. So I'll say task.continue with, and I want to continue this task with another action. And this action happens to take the previous task as an argument. So I'll have a lambda which takes a t, and the t refers to the original task, the one that has been completed. So here, let's write line, for example, completed task, and then t.id. And now we can pour water into the cup, like so. Okay, so we have yet another task. Let's call it task 2. And now we can simply wait on task 2. So I can say task 2.wait, like so, and we're going to wait for it to finish. So when I run this, we boil the water on task 1, then we completed task 1, and we pour the water into cup, which is obviously happening in task 2. So the use of continuations comes with its own overloads of the continue with function. If we look at the documentation here, you can see that there are typical things here like providing the state, for example, providing a cancellation token as well, specifying task continuation options, some of which we're going to see in a while, and specifying even your own custom task scheduler if you want to have your own mechanism for scheduling the different tasks. So that's a very simple example of continuations. Let's take a look at something different. Let's take a look at a situation where you have two tasks that don't really do anything, but they return results. So let's have var task equals task.factory.startNew. So I'm going to have the first task, which returns the string task1. Notice in this case, instead of console.writeLine, I just return a string. I have the string as the result of the lambda, which means this is a task of string. And I'll duplicate this like so. And I'll make task 2, and that's going to return the string task 2. Now, if I want to continue, when both of these tasks are completed, I can create a continuation where many of these tasks are continued by one particular task, a kind of one-to-many relationship. So I can say var task3 equals, and then I can say task.factory.continue when all. And continue when all requires all the tasks to be completed before this task is complete. So I can specify the tasks I'm waiting on. These are task and task 2. And then I can obviously specify the lambda. So here I can take a lambda, and notice this time around the lambda doesn't take a single task, it takes an array of tasks, an array of task string in fact, and this lambda goes to the following. Now here I have the results of the invocation of the two tasks, because remember task and task 2, they both return a string, so I have those strings as results. So I can first of all write line the fact that tasks have been completed, and then I can iterate through the results. So I can say for each var t in tasks, I can say, for example, I can get, let's get the printing done correctly. So I can have the dash and then just return the result. So I'll get the result of the task. Seem to be failing with code completion here. And finally, I can write line all tasks done. So this is my setup, and now of course what I can do is I can simply wait on task 3 for the whole thing to complete. And as we execute this, you can see that task 1 and 2 are completed, they return their results, and then my continuation, which waits on both of these tasks, basically prints task 1 and task 2. In addition to continue when all, there is something called continue when any, which is going to execute as soon as any one task is complete. Now, obviously, in this case, the Lambda doesn't take an array of tasks. It just takes a single task T. And in this case, what we can do is we can simply comment this out and just print out the result. And we don't know if it's going to be task 1 and task 2. I'm guessing it's task 1. So no, I was actually wrong. It's task 2 here because that completed first and nobody really waited for task 1. It just completed one of them. And so that's what gets output. So as you can see, continuations are a very simple mechanism for specifying how a particular task follows on from another task that's being completed before it.